Okay, so let's look at this one. So now this is involving inverse trigonometric functions. Okay, so notice now we have cosine inverse of 1/2 and sine inverse of 3/2. Okay, now again, these represent angles. Okay, so don't get confused by this. Those inverse trig functions represent angles. Okay, so we can still apply the sum and difference formula here. Okay, so just think of this as an angle, angle 1, and this is angle 2. Think of this as alpha, and this is beta. Okay, and then just apply the formula. So let's do that. Okay, so now we're going to say, okay, just think about what's going on. So it's going to be sine of the first angle, which in this case is cosine inverse of 1/2 times cosine of what? Oops. Okay, cosine of, oh, hold on. How do I want to do this? Cosine of sine inverse of 3/2. That's what I want. Okay, so that's the first one. Plus, right? Plus sine now of the second one. So this would be sine inverse of 3/2 times cosine of the first one, which is cosine inverse of 1/2. And so now that's what I have. So now it's time to simplify things. Now, it's always handy to write out your triangle. Oh, and it's also handy to realize that when are these defined? Okay, when is sine and cosine defined? Okay, now remember cosine is defined on the interval from 0 to pi, and sine is restricted to negative pi over 2 to positive pi over 2. Okay, so that's important to know. Okay, so both of these you want to make sure are in that range, right? So basically in the first and second quadrant, right? For cosine, or excuse me, yeah, for cosine 0 to pi. So the first and second quadrant, and sine is in the first and fourth quadrant. Okay, so now cosine of 1/2. Now 1/2 is positive, right? So cosine of 1/2, right? Cosine is opposite over adjacent. Or excuse me, cosine is adjacent over hypotenuse. So you've got what? 1/2, and this has to be the square root of 3. This is 60 degrees. Okay? Okay. And what about sine of 3/5, right? So we're asking ourselves what angle, right? So what angle has a cosine of 1/2? That's going to be 60. What angle has a cosine of 3/5? Has a sine of 3/5? Well, let's draw our right triangle. And so opposite over hypotenuse, this is going to be 3/5, and this is going to be a 3-4-5 triangle. Okay, and this turns out to be a special triangle. Okay. And so here's the angle. And so what is cosine? Right? So right away, sine, so we've got our triangle, right? We found out, using inverse cosine, we found this triangle. So now what is sine of this angle? Sine is going to be square root of 3 over 2. Okay? Now, what about this? We got this triangle, right? So inverse sine of 3/5 gave us this triangle. So now what is cosine of this angle? Well, cosine is going to be 4/5. See how easy that is? Now let's do the second one. Now we've got, again, sine of 3/5, right? Inverse sine of 3/5. Okay, so now if it's inverse sine of 3/5, now our triangles are going to change a little bit, right? So now for this angle, it's opposite over hypotenuse, so it's going to be 3/5, or I'm not, yeah, 3/5, so 3 over 5, and so that means this is going to be 4, which means the sine, oh, wait a minute, even easier, we've got the inverse property here. So we get sine inverse here, sine inverse, and we get sine, so this is just going to be 3/5. So I overlooked that. And same thing here, cosine and cosine inverse, that's just going to give us 1/2, using inverse property. Okay, so we use the triangles for this one, but we don't need the triangles. We could, but again, if you notice that it's just inverse property, it's easy. Okay, so now we simplify. So this is going to be 4 times the square root of 3 over 10 plus 3 over 10, which then gives us our final answer of 3 plus 4 root 3 over 10. And that's the way I would leave it. Okay, I wouldn't simplify it. Just leave it as a fraction. Have a great day.